Making a schematic is going to force you to fill in all of the little details that you need for your design, and that includes um, component selection. So this is potentially really overwhelming, I'll admit, because there's a ton of choice when it comes to picking components. But a good starting point is to take your breadboarded prototype and any dev kits or breakout boards that you've used. Those will almost certainly have some kind of schematic or layout information available online. Or you can always just see what are the major components they've used, which ICs, and basically just check those data sheets. And on that as well, actually, just as part of this process of component selection, you will be reading a lot of data sheets. And it's not something to be intimidated by, but it is, I'll admit, data sheets are written by technical people with the expectation that the audience is also technical. So they can be a little bit hard to process to begin with, but they do have a lot of really useful information. So as an example, here's a random IC that I found, or that I literally just picked an IC at random, and it has a typical application schematic with all of the component values and some explanatory notes on those. And actually, this particular data sheet goes even further, and they have a recommended layout section, which I will caveat by saying that the recommended layouts typically are made with the expectation that this is going to be assembled with pick and place. So the components potentially are going to be quite small and quite densely packed together, but it still serves as a really good reference or as a really good starting point for your designs. There are some criteria that you can use to help you with your selection process, because without it, it would be totally overwhelming. I like to consider power consumption, cost, size, performance, and manufacturability. And so let's get stuck in with power. So especially I do a lot of battery powered devices, so this is particularly relevant for me most of the time. So the terminology you're going to be looking for on data sheets will probably be like quiescent current, which is a fancy way of just saying the current that's drawn when the IC is switched on, as well as shutdown current. Shutdown current is when an IC has an enable pin and you've turned off the IC, well, it still actually draws a little bit of current and is consuming a little bit of power. So if for a battery powered device, these can really impact the expected battery life of your device. For cost, seems fairly straightforward, really. You you want to not overpay for what you're getting, but actually it goes a little bit more in depth than that. So when you're looking at prices, you will often see some kind of a price breaks. So like if you buy one versus 10 versus whatever it is, 25, they'll even do like Mouser will do like 3,000 units. We'll get a different price point. Something to bear in mind there. Um, and similarly, you'll have potentially big price differences between something like LCSC, which is Chinese, versus DigiKey or Mouser. So LCSC, the prices might be lower, but the DigiKey and Mouser might have the shipping time would be lower, but you offset that with your higher costs. Something that is worth caveating as well is that counterfeit ICs do exist and they are a thing, and there is a slightly higher risk of that coming from if you do go to a Chinese supplier, LCSC, Alibaba, wherever you go to for your components. As a hobbyist, it's never impacted me, but it's something to bear in mind. This is more really for the non hobbyist, the professional side of things, where this really becomes problematic. But it's something that's worth mentioning at this point. Size, we're talking here about the actual physical dimensions of the package. There can be a big range actually in terms of size, from say a tiny BGA to all the way up to your STM32s that love to be like a little spider. So you might have BGA that's got a nice small footprint, whereas STM32 loves the long legs that are really easy to hand solder. Personally, I prefer to go as large as possible, especially for my passives. Um, I say as large as possible for the passives. Passives, I typically go 0805. I find 0805 is a nice sweet spot between, you still need tweezers to place them, but they're easy to see and easy to handle compared to the smaller ones, without taking up too much space. But especially for your ICs, I would go as big as you can. But that is sometimes dictated by if you have a particularly restrictive size constraint, you might not have a choice. Performance. So microcontroller performance will have, if you have an interest in just computers in general, it'll be all of the terms that you might be familiar with. So your clock speed, megahertz, your core count. You may find some products have co-processors, low-powered co-processors that you can offload, especially I/O tasks to. I know that I think it's the ESP32 has two cores so that it can handle the Wi-Fi stack, something like that. So it isn't just about clock speed. And of course, we've got memory as well to consider, both volatile and non-volatile. Non-volatile, of course, you can supplement with an extra flash IC or whatever you want to use. But that capability depends on the capability of the MCU that you choose. So it all meshes together, these component choices. A decision that you make on one component may have a knock-on impact on decisions you make for other components. So that's mostly true with the microcontroller, but it could be true with others. There are okay, yeah. In terms of performance, there are some other bits that I would say are not most of the time not going to be relevant for the hobbyist kind of market, but if you need to care about these specs, then you will know. So it'll be stuff like slew rate or timing, like specific timing of voltages or whatever. I don't know. There's so many possible things that you could have, but for the most part, these are probably the main ones. For manufacturability, essentially the question is, can I make this? Or can I make this easily? So that's why I was talking about I choose 0805 passives. If you have a pick and place, then this question gets much easier for you and you can basically choose whatever you want. But if you're hand assembling things, then you should consider how you are assembling them. So are you hand soldering all of your components? Well, if you are, then either choose at least 0805 and ICs that have legs that you can actually reach with the soldering iron. Because if you go for something with no leads, then you'll end up with pads that are underneath the IC and you'll have no way of. You can do it, but it's really difficult to get in there with the soldering iron because the soldering iron tip will be like this big by comparison. And also you should consider PCB, the PCB manufacturer, what their capabilities are. So every manufacturer will have a capabilities page, and some manufacturers, I know JLC PCB will charge differently based on what capability you need. So for example, if you here, so this is JLC PCB's capabilities page. So for example, if you went for if you go for vias, for example, they specify a minimum via hole size and diameter, but what they don't say is when you actually go to make, you go and have something made, they have two price point, or they have more than one price point for vias. So here, minimum via hole size, they have these different selections, and each of these will be a different price point. So there's the minimum that they specified, 0.15, whatever, a hole size and so on. But actually, if you want the cheapest one, you're looking at 0.3 millimeter hole size. So that's something to bear in mind, what the manufacturers can do, and then also at what price points. That's going to influence your decision in terms of capabilities. And that then itself may influence what parts you choose. So especially BGAs or something similar, well, oftentimes those balls are really close together. So you've got minimum pad size issues, and if you need to get a via either in the pad, which looks like if this is the pad and the ball sits on top of this, you might need a via inside it to then, on an internal layer, to route out that signal, because you might be able to reach all of these external ones, no problem, but the balls can be so close together that you can't get in there with a trace without violating a minimum trace gap. So you have to go on an internal layer. Then, if there's no space for a via around it, you need a via in pad, and that's a whole potentially another layer of cost. So, long way of saying, also consider what the manufacturers can do. That it will be the case that a manufacturer can almost certainly do what you want. It's a matter of how much you're willing to pay for that. And then as well, going back to how are you making it, also consider the potential for if you need to do any rework or any sort of bodges, really. Say, going back to the no leads example, well, what you could do is when you have your footprints on the PCB, if you were to extend the pads out just in case, because what that would give you then is a surface that if you needed to bodge a wire onto it, you could, because otherwise there wouldn't be any way of bodging that connection unless you put some kind of a deliberate test point or something in somewhere else in the PCB. Something to consider. And that may then, if you decided to instead just go for the spidery STM32s, well, those legs, not only are they great for getting a oscilloscope probe attached to them, well, they're actually also really makes it so much easier if you need to solder on a tiny wire to bodge a fix. Right, so that's a lot about criteria. Well, how do you actually find these parts? The unfortunately, you just have to search. Is the basic approach. So that will be you search Mouser, you search DigiKey or whatever. I'm just using DigiKey, LCSC, and so on, just example names. But the search tools they have will let you input ranges for values, for input voltages or for output voltages, whatever criteria is important for your particular IC that you need. You should be able to search for a window of values that match your criteria. And then it involves, reading. This is where you'll be reading a lot of data sheets to determine is this chip, does it fulfill the needs that I have? Have I understood it correctly? Sometimes it might show up in a search, but actually it's not appropriate. It might hit a few criteria, but not all of the criteria you need. In which case you can just skip to the next, the next one. And as well, you then once you've done your search, then you need to be considering all of the other parts. So like cost, package availability, minimum order quantities. But usually, if it's from Mouser, DigiKey, or LCSC, you should be all right. What I will say is, once you have identified a part, finding a source for those parts is much easier. So, to be honest, finding the part name that would work is the hardest bit, because you've got stuff like Octopart will let you input a part name, and then you can see where you can buy it and at what price point from different places. And of course that often shows up in Google. The other thing, and I'll say this just because we're in the AI era, is that something like Claude AI or Mr. GPT, they can give you suggestions for part names. I have about 50% of the time, Claude has given me part suggestions for parts that don't exist. There are research modes and they can search the web, but I would say if you're going to do this, use it as a starting point only, and then do the follow-up research, check the data sheets, and then see if anything else exists, maybe in the same family. But it's not a horrible way to start, but it can lead you into some dead ends or into some funny situations with parts that don't exist. So we've identified the parts that we want. So now we have to buy the parts. It seems straightforward, right? You just find the parts you want and you buy them. Well, something I would suggest is over buy. So if you do a PCB run and you only get 5 PCBs, I typically like to get around 10 of each of an IC, and I like to get 100 of passives. Partly that is because you'll be saving on shipping costs and time. Passives, you can reuse in different projects or in different hardware revisions of your boards. ICs, typically I would say that unless you're really experimenting, buying 10 ICs is fine. If you do another board revision, you'll have more. And let's say, for example, you buy 5 of a first revision, you will probably make 2 to 3 of them as a test. Maybe you made mistakes along the way, and so you will have a bunch of ICs left over, well, those can feed into, maybe you do 5 lots of revision 2, well, you don't have to buy any new ICs, any new passives, unless you change those bits. So I like to overbuy, buy once, and that will hold you through a couple of hardware revisions in theory, for the most part. DigiKey and Mouser, they do have fairly expensive, something like £30 minimum if you want to get free shipping. That's not a lot, but it is if you just need to buy one IC, because you let's say you only bought exactly as many ICs as you needed, and you drop one and it disappears because it's so small, or you burn one by accident, the magic smoke comes out, and now you just need one. Well, now you're paying like £7 shipping on a £2 order, and you're going to have a bad day. So make sure, long story short, make sure you overbuy slightly, not ridiculously, but slightly. And that is pretty much it, to be honest. There's a lot in here, and again, with everything, each of these things, each of these points can go into more and more detail, but we're just building up that picture. So what I will say is that component selection is only one part of schematic building, schematic creation, but it is something that you should be thinking about from the beginning, because as you put together a schematic, you will then solidify some of those decisions of what components you want to use. And as you do that, you are then going to have to make a decision of what you want to use. And most of the time, you don't have to do a schematic in one go. You can say you start with the power supply in your schematic. Okay, well, now I have to figure out the power supply. I know how much voltage in, voltage out I want. I know how many amps I need to supply. Okay, now I can make the power supply. That could be completely separate from your microcontroller choice. So you can just do little pieces of the schematic as you go, until it all comes together. There will be some things that you need to make a decision on as a whole, but usually the sort of modular approach is the way to go, and having this in mind from the beginning can really help you with that.